All right. All right, welcome back. We're entering the week of our course, and as promised, this week we're going to be talking about Passport.js and user authentication and user management in general. We're going to be talking about user management for the next couple of weeks. But let's focus on user management for forthcoming couple weeks. Right. So user management or authentication is a service that should be framework wide, right? That it shouldn't be the responsibility of any. It should not be spread over many different controllers or many different entities. So it should be configurable in one single place, right? So that you don't have to deal with it in various different ways, right? So, for instance, one of the things that we looked at when we were implementing the profile controller and the admin controller, right, is that and if you remember, we did that using resolves, right? We added a resolve to the profile page. We added a resolve to the admin page, to the home page, and basically that mechanism worked so that it would intercept the communication, or it would intercept the intentions of the user, right? And it would look at it. It would look at the intention, and then it would check to see. It would verify whether that intention was okay or not, and it let you through or not. Okay. So instead of spreading the logic across different places, we put it in a single place, right? And then anywhere when we wanted something protected, we just make sense. Whenever we wanted if we have a whole bunch of pages. Any page that we want protected, we would put a resolve in front of it, and then we would be done, right? Instead of having to do the logic in many different controllers. That make sense? And so this was all on the client side. This was all on the client side. On the server side, we're going to do something similar. On the server, we are also going to intercept certain communications, right? Anytime we try to navigate to a URL, right, we need to determine whether that URL is valid or not. Okay, just like we are trying to navigate in routes on the client in Angular, and we want to block certain people from going to certain routes, we have to do the same thing with the URLs that go to the server, right? Using a similar mechanism of intercepting these URLs, right? Doing some checks to see if it's okay, and then letting them through or not. Make sense? Right? Well, in Express, it's fairly easy to do these interceptors, right? These kind of logic to inject this interception of the request. Right up to this point, we have been using chains, but our chains have been very, very short. Right? Just one single hop. Okay, the incoming request came in. We handled it, and then we responded. Okay. Node.js or Express Node.js allows you to create sequences or chains of handlers, of request handlers, so that they can be all connected to one another, right? So that you can have all sorts of pre-processing, right? That happens, pre-logic that happens, whether the request should continue or not, okay? Whether I should let a request go through or not, okay? So Passport.js uses this mechanism, right, to inject itself or to allow you to inject a logic that should happen every time you try to go into a particular URL or a particular route. Okay. In the client on AngularJS, we use what I call resolves, right? And then we provided a function that needs to be executed before before you let somebody through or not, right? And then we resolve or we reject it. Remember that? Okay. Well, we have to do something similar. Not exactly the same way because it's not Angular, right? And it's not in the client. This is on the server, right? But the idea is the same. It's the same idea. We're going to try to inject ourselves into the request, look at the request that's coming in, and says, you want to go to the admin page. Wait a minute. You're trying to list all the users. Wait a minute. You're trying to delete a user. You're trying to change your role. You're trying to, all the URLs that come into the server, we would like to intercept them, right? Check to see if that person is logged in, if they're in the correct role, if they're allowed to do these things. If it's okay, then we just let it through, like has been already behaving. Okay, so the behavior that we have already, right, on the server side of logging in and registering and going here and there, we've only been protecting it on the client side, right? We've been protecting it on the client side, and that's not enough. The client side is a public place, right? The source code is available to other folks, right? They can read this, they can reverse engineer our code, right? And they can find weaknesses on the client side, right? So any security that we implement on the client side has to be backed up with server-side security as well, okay? Because a savvy software engineer can look at the requests, right, and the HTTP requests that go back and forth and try to deduce, right, what is it that they can use some tools like Poster, right, that allows you to programmatically send posts and puts and deletes, right? They can create their own clients. They can create their own JavaScript, right, or manipulate their JavaScript. So to try to thwart the client side, the client side security, right? So any client security is not enough all on its own, right? It needs to be backed up with a server side security. Make sense, right? So what we're going to use, what Passport.js does is that it uses Express's ability to create these chains, right? Now these chains, and any reason you might want, right? Passport.js uses it to protect URLs, right? In your case, you might do some pre-processing of the data, right? Maybe the data is in a particular format, right, that comes from the client. You might want to do some transformations before it gets to your handlers, or your HTTP handlers, okay? Or then right, you might do some transformations in there, right? You might do some data modeling in the filters, right, that intercept before it gets to you, right? You might do some validation in the filtering, right? You might check to see if you're expecting certain pieces of data and they were not there, they're not the right data type, they're not the whatever, right? Instead of doing it down the road, right? So that by the time it gets to your web service, right, it's already validated, it's all the data is good, right? So you could do some centralized logic, right, that could happen early on before it even gets to your web service. Okay, so the way we've implemented the web services is by mapping a URL to a function. Even that mechanism follows the same idea, right? Somebody has already intercepted the request for us, right? So there's a low-level filter, there's a low-level request handler that is implemented by Express, which does a lot of magic for us, right? We just get two objects, request object and response object. How did that happen? Somebody must have intercepted it, right? Somebody must have parsed the headers. Somebody must have parsed the all the parameters, all the query parameters, the URL, the IP address, the time, all the cookies, right? The body that was embedded, any image upload files that were embedded there, and provided nice objects, the request object and the response object. So somebody has already done a lot of pre-processing for us, right? Okay, and then they create this abstraction, right? That so you don't have to deal with the nitty-gritty of the ASCII text that is coming through the request. Right? It parses all that and it creates us these two nice objects. Yes? Well, just like you can create this function that is mapped to this URL, you can create other functions. You can create other functions that can tag along one after another, right? And the way they would communicate with one another is by a third argument, not only request, response. There's a third argument that comes along there, which is the next object. Well, it's not an object; it's a function, right? That allows you to, intercept the request. You say, well, that you want to continue with the next function in the chain, right? You have two choices. At each level, at each step of the chain, you can either, take the request. You can either generate a response, right, and then the request is fulfilled. It's done, right? It goes back to the client. Or you can decide, I want to go on to the next element in the chain, right? And then the request and response gets passed to the next one in the chain, right? Again, you read the request, you do some logic, and then again you can choose either to just generate the response or call next to go on to the next one, the next element in the chain. Up to this point, we've only done the response. We've never used the next, right? So today I'd like to talk about that, right? How to use this this capability of chaining together several functions so that they can communicate. You can break up the work, right, into several of these functions in a chain, right? One of them might check to see if you're authorized. One might check to see whether you're logged in. The next one might check whether you're in the right role, right? The next one might do some validation on the users that you're passing along, right? At any point, if you find in the request something is wrong, you can always just respond, right? So the first one might check whether you're logged in. It says yes, okay, you can go in. You can continue. You call next. They're logged in. And then the next one says, okay, are they in the right role? Right? If they're in the right role, you say next, go on, right? Or at any point you can say, are they authorized? No, I'm going to respond with a 403, unauthorized, right? Or if I call next, yes, they're authenticated. They say who they say they are, right? You call next, you check within the admin role. Again, if they're not in the admin, if they're in the right admin role, you call next to the next one in the chain. Or you can fail it and say you can respond with an error, 403. Right? Again, unauthorized. Right? Up until you get to the final place, right? Okay, so I logged in. Finally, I'm here. I'm an admin. I was trying to, retrieve the list of all the users. Only admins should be able to do that, right? Okay, so we'll like to talk about that today. The other thing that I'd like to talk about is the fact that applications like we're building, protecting single-page applications is just a little more involved than protecting server-side web applications. Okay, server-side application, you might be familiar with it. You might have already built some of these using ASP or Python or JSP. Right, these are all server-side technologies, right? Where these execute on the server, right? They generate the HTML dynamically, right? And then the client just gets the HTML. They never get any source code, right? The source only lives on the server. It executes on the server, right? Protecting those kinds of applications, it's easier, right? Because you're just protecting whether you have access to a page or not, right? Can you even go to that page or not, right? Protecting client-side application is a little more involved, right? Because half of the application in a single-page application, half of the application lives where? In the client, right? And JavaScript, source code is running on the browser. Almost half of the application is on the browser, right? The other half lives on the server, right? And so you need to protect both. Right? On the client side, you have to protect navigation. Can you go to the profile page? Right? We did this already using Resolve. Right? Can you go to the profile page? Can you go to the admin page? Right? So we did this already. Now we have to protect the rest of the application. What's the rest of the application? It's the API, right? It's the API URLs. Because remember, half of the application lives on the browser, but it has no data. It has to go back to the server to fetch all its data, right? It has to go fetch the currently logged in user, the profile information, the search results, the details. And the way the client talks to the server is through this API that you create, right? These web services. Well, they need to be protected. Not only do you need to protect the navigation, can you go to a page, but once I'm in that page, am I allowed to use the API to go fetch data, right? Perhaps most of the read operations will be public. Anybody be able to list, get a list of all the users? Probably not. Should anybody be able to go do a get on /API/user? That lists all the users, right? Should anybody be able to do that? No, right? Perhaps just an admin. An admin user might be able to list all the users, right? Should anybody be able to change their role? Or update, an update. Well, everybody should be able to update themselves, right? If I'm looking at my profile, I should be able to update my profile. What about somebody else updating somebody else's profile? That should not be allowed, right? So there's a lot of things that have to happen on the server side, protecting the server side, right? So I'd like to talk about that today as well. So a lot of these issues that I've been discussing, I've implemented a sample project that I've shared with you on Piazza over the weekend. Right? It's a very minimalistic mean stack application that uses Passport.js. Right? I try to make it as minimal as possible so that you can find pieces here and there that you can copy and reuse for your own purposes. Right? I like to feel free to reuse some, all, or nothing from this project for your own, for the assignment that's coming up. The assignment is coming up later this week, and also for your own project. Right? For your own project, you'll need to implement. So I'd like to go over that today. Okay. All right, let's see. So it's should be under there. It's this one right here: mean stack authentication and registration with Passport. Okay. So if you could clone down this project, right, and take a look at it yourself, play around with it, install locally, and run it. The only thing you'll need to do when you download this, you'll need to do an npm install, and MongoDB needs to be running. Those are the, all right? Should be easy. Creates its own database and whatnot. So you should be all set. All right. So I like to look at the implementation here. I've cloned it, and I like to run it for you. What's this? Okay, let's see. WebStorm. Now, some of this is, a lot of this are things that we already see, right? A lot of it is, the Angular side of this, controllers and services, and the templates is things that we've already seen. So I'm gonna go through that quickly, right? Because I assume you already know the templates and the controllers and the services, right? I'm only going to stop and go when we talk about something that has to do with Passport.js. Right? But if you need me to stop and review something that we've already seen, please don't hesitate to stop me, and we can go over it here together. Right? So let me close this and reopen. Let's see, mean stack authentication and registration. All right. Okay. So let's see. Let me. I already done an npm install, so let's run this. So I'm running it. Okay, so here it is. It's very simple, home, login, register, and some of this we've implemented using session before, right? And we're gonna build on top of that, right? So that instead of using plain old low-level session, we're gonna use Passport.js. Okay. So here you can log in. Right? You can log in as Alice. Alice happens to be an administrator, right? So Alice has this admin link up there, right? That only administrators have. And notice that the links appear and disappear depending on whether you logged in or not. So for instance, notice that the login link is gone, registration register link is gone, but now I get a couple more links, profile and logout, and admin if I'm an admin user. So if I go to the admin user, only an admin user can see a list of all the users in the system. Right? Only an admin user can delete all the users. Right? Only an admin user can change somebody else's information. Okay. Only an admin user can change a user's roles. So for instance, Alice can change Bob's roles. Notice the roles here is an array of strings. See that? It's an array of strings. In the server, right, in the schema, right, roles is implemented as a string array. So roles colon array of strings. Yes? Right? Display it displays like this, like an array of comma separated strings. See that? But when you're going to edit it, so for instance, if as being Alice, I can click on it, it renders as a string, right? As a string of comma separated strings like this. If I edit it and it goes back to the server, it's going to go back as just a single string. So faculty, say OK. Right? It's going to go to the server as a single string. I need to convert it back into an array string by splitting it over commas. Right? I also have to make sure that the person who's updating the user right now is not a regular user, is an admin user. Right? We wouldn't want a non-admin their roles to be themselves admins. So when I update, it goes back to the server splits this string into an array of strings, and then when it comes back to the client, it's again an array of strings. Okay? I believe in the assignment I asked you to do something similar for the emails, right? Where you have a list of emails, right? So on the client, that's just a string of a comma separated string, right? But when it's represented on the server, it should be represented as an array of strings, as opposed to a string of a comma separated string. Okay, so but you should look at the code. We'll look at the code a little later to see how this is done. So also, only an admin, right, can remove an existing. Okay. Notice that the way we navigate it here is through going to the admin URL. I can go to profile or admin. Right. If I log out and I try to log in as, okay, there was somebody there that was not an admin, I forget. Who's not an admin? Okay, Jane is not an admin. Jane is only a student. Right. So if I log in as Jane, I go to the profile, but notice I don't have the admin link. Okay. Even if I try to navigate to the admin page, it will not let me. Right? Even if I overlook somebody typing the URL, it won't let me. Right? I can go to the profile. Right? Or if I log out and I try to go to the profile page, right? It'll stop me and kick me back to the login page. Okay. Okay. So this is very simple. I like to go over it. It uses Passport.js instead of string cookies, right? Like we did earlier. It builds on that, right? For Passport.js to work, already configure the cookies in a session, like we did a couple weeks ago, right? We configured the session and the cookies, but it doesn't use the session and the cookies directly, right? It instantiates its own session information on top of the session implementation. Okay, so I like to show you how the code works. Before we begin, just a short overview of Passport. So Passport is a middleware, right? Meaning it's something that is meant to execute on the server, and it's meant to provide services in between two worlds, right? So incoming requests and other services that need the service of this middleware. Okay, it intercepts incoming HTTP communications, right? And then it lets communications go through or not. Okay. Now its fame comes from providing is consistent throughout any number of authentication strategies. Okay. So what it means is that Passport lets you very easily integrate with different ways that you can authenticate yourself. You can authenticate yourself using just plain old username and password. You can authenticate yourself using Google or Twitter or Facebook, Google, right? Any number of authentication strategies. Passport calls them strategies. Okay. Now each one of these authentication authorities, right? They all have their own quirks, right? They all have their own specific way of authenticating, right? And if you want to integrate with them, you would have to learn how to work with each one individually, right? So what Passport does is that it creates an abstraction. And it creates an abstraction layer so that you don't have to deal with each one individually, right? It provides the same API across any number of these authentication providers, right? So that it's much easier to learn, right? So that you have to learn just one way, right? And then let Passport deal with the idiosyncrasies of each one of them. Just like jQuery, right? Before jQuery, you had to learn the JavaScript of different browsers, different versions of browsers, and you had to do all these checks, right, to see that if you had this and that and the other, right? And you had to deal with the idiosyncrasies of dealing with the DOM and dealing with all these things. What jQuery did is create an abstraction layer, right? So that you don't have to think about, oh, I'm running on this version of Mozilla, or that version of Safari, or that version of whatever, right? Instead, it provides a consistent API, and it converts that API to the low-level idiosyncrasies of each browser that you're working. Make sense? So Passport.js tries to do the same thing. One API to rule them all. Now, there's tons of strategies. There's quite a bit of strategies, and Passport, they advertise, how many strategies they support, right? Facebook, and Google Auth, and Twitter, and Google, LinkedIn, and there's a whole bunch of them, right? Tons and tons of these, or Steam, right? And each one is documented in their own GitHub repository, right? So if you want to look at the implementation and the source code, how it's implemented, right, you can go to each one of these repositories and take a look at that, right? And each one has their own npm install, right? So Passport is made up of a core Passport API plus any strategies that you want to use. Right? Today we're only going to look at the simplest of strategies, right? Which is the local strategy, just logging in with username and password. Okay. Next week we'll look at being able to log in Google or any other strategy. But first, I'd like to introduce the simple strategy, right? It's referred to as the local strategy, meaning you can authenticate with a local authority, right? Implemented by you, which is basically, I'm going to go see if this particular username and password happen to be in the database, in my database, right? I'm not going to try and integrate with some third-party authentication authority and have them check their database. I'm not going to do that just yet. Right? That's a little bit different. So first, let's look at us implementing our own local authentication authority, right? And then next week we'll revisit this using third-party authentication authorities, right? So yeah, so we're going to look at the local strategy. 307 strategies, right? So they allow you to integrate with all these ways of authenticating yourself. All right. Okay, so let's start at the beginning. All right, so first of all, you'll need to install a couple of things for this to work. Right? You'll need to install some things that this depends on. So Passport.js depends on cookie parser and session to be already installed, right, and already configured, right? And first you have to install and configure these two things. Then you can configure Passport. And configure the session and the cookies. Once they're configured, then you can configure Passport on top of that. Right? So after those two are installed, you'll need to install the core library, the core Passport library, and then any combination of strategies. Well, at least one. You need to install at least one strategy. Okay. Usually, at least the local strategy. So it's implemented in its own Node.js module. Okay. All right. Then on the server, you'll need to import or require first the two dependencies that Passport has. Right. It depends on the cookie, right, and it depends on the session. Right. Passport is going to use the cookie and the session to store information to remember that you have been logged in. Right. Actually, Passport can work without the session. It could work without the session, but it would be very annoying, right, because Passport would not remember that you have authenticated yourself. So say you try to go to a particular page, right? And that page is protected. Passport is going to challenge you for login. And you log in. And now and then lets you through. Now imagine that you want to navigate a page that is also protected. Right? Because Passport doesn't remember, it's going to challenge you again and ask you to log in again. And then once you log in, it lets you in through. Right? That would be very annoying. So instead, Passport optionally can use session to remember, at least for the time being, at least for 30 minutes. Okay? And the way it works is that Passport uses a session, uses a cookie to store information on the cookie. So next time you try to access something that is protected, it'll first check the cookie to see if you're still in session, if your session is still valid. Right? If it's valid and you've been authenticated, right, it'll let you through. If it's not valid, and then it will challenge you. Make sense? So yeah, so that's why we're going to use the cookie parser and the session. So first we require cookie and the session. Then we initialize the session, and we initialize the cookie parser, and that has to happen first. That has to happen first. First, the session and the cookie. Once they are instantiated, once they're configured, right, then you can go on and configure and initialize Passport. Okay, so Passport is configured very easily. You just say passport.initialize. That's it. Passport.initialize. And optionally, if you are using a session, which you should, right, then you say password.session. Right? And password.session is going to use the session you've already configured. Right? So that's why it has to happen in that session, then password.session. If you try to do it in a different order, it's not going to work. Remember, right? So if Kelsey start asking, why is my password session not working? First thing I'm going to ask you, are they in the right order? Okay. Also, make sure that when you install these packages, these new packages, right? Make sure that when you install these new packages, you do save npm install passport --save. Don't forget to do that --save. I've seen a lot of people come to me and says, why is my OpenShift not working? And the first thing that I compare your package JSON, I compare it with your node modules. There should be a one-to-one mapping, right? All the modules in your node modules here should be listed in your dependencies, right? So when you see OpenShift that's not running, first check this, because that's a very easy check, right? Are all the modules listed in node modules listed also in my package JSON, right? If it's not, then install it again, right? Doing a --save. Make sense? All right. Okay. All right. So in the server, you created a session, the cookie parser, and the passport. That's it. That's all you need to do to initialize passport. Now, passport, when you call .initialize, right, what it's going to do, it's going to add several features to the existing Express API. So the existing Express API is what? It's the thing that allows us to create URL patterns and map them to functions. That's Express, right? The callbacks that it passes the request and the response. Those objects, request and response, but that's Express, right? Express creates that functionality. Okay. Well, Passport, right, takes Express, the Express objects, it adds additional behaviors to it. For instance, one of the things that it adds is that if you successfully log in, right, the currently logged in user will be saved in the request.user object. There's going to be a brand new user object in the request. Right, we're already familiar with the request, right? What's in the request? The params, the body, right? The query is there. Okay. Well, Passport is going to add one more thing in there. It's going to add the user. The currently logged in user will be available to you through the request object. Okay. Right. Also, it adds several other functions that are nice utility functions. They're right. When we did the implementation using sessions to do some user management, what was last week? I think it was last week, right? We used session.currentUser. Remember that? Session.currentUser. To check whether somebody was logged in, we checked to see if session.currentUser was not null, right? And to log somebody off, we did session.destroy, right? When somebody was logged in, we did session.currentUser equal the current user. Remember that? Okay. Well, in that case, we were using the low-level session object. We were manipulating the low-level session object and removing things from the session, updating the session. Yes, but that's just one way of logging somebody in. What if you were using instead Google or Facebook or something else? How would you do the login and the logout and all that? It would be some other way, right? Some other way. So instead of having you to deal with one way when you're using this, when you're using another strategy, it hides that from us by providing methods for us, high-level methods. Right. So for instance, if you want to log yourself out, instead of going to low level and updating the session, Passport provides us with a function .logout, request.logout. That's it. Now you're logged out. Now, obviously, what it's doing is updating the session down underneath. Yes? But that's hidden from you. You don't need to know that. Right? Again, because that's specifically for the local strategy. You're updating the session. Right? For other strategies, it might be something else. But it's the same logout function. You see that? Same thing. What if you want to check whether if you're logged in? Right? Again, Passport provides a high-level function for that. You can just ask your request is authenticated. Right? Which is true or false, whether the user is in the current session or not. But that's if you're using the local strategy, right? If you're using some other strategy, it would be something else. But again, those details are hidden from you with this high-level is authenticated. Make sense? So yeah, so that's the beauty of Passport, right? Of creating this high-level abstraction of authentication. All right, there's Passport. All right, so let's start logging in. Let's see. On the client side, we have a couple of views. We have the login view. All right, let's look at the login view. So the login view allows us to log in, and when we click on the login, it's handled by the login in the controller. So here's the login, and login uses user service, and it passes the user to this login user service, which is implemented here. Again, I'm not stopping for the controllers and the templates. I'm assuming that you're familiar with this already, right? Templates and controllers and services. I'm only going to stop when there's something new about Passport. Right? All this is the same. You know, we've been doing it for several months already, I think. Yes.
Professor, you just said about the Passport using sessions, manipulating sessions, low-level functions,
yes.
using some abstract functions. So that's only when we're using sessions. You said it's always recommended to use sessions along with Passport, but it's not necessary.
Yes, it's in the case where you're if you're not using any session, it's not remembering anything, right? So you're always logged out. You never logged in. You're only logged in. The request is logged in, right? But then it doesn't remember whether you logged in or not, right? So you would always be logged out.
But still, those functions would not.
Well, then they would make no sense, right? Logout is I want to forget that you were logged in, right? You would use the authentication. The authenticate would work, right? Meaning you have gone through the login. I have looked you up in the authentication. I have found you. You are logged in. Okay, I'll let you through, right? But then if I don't have a session, that's where it would end, right? I would now be again logged out, right? Because there's no way for it to remember that I already authenticated with you, right? Okay. Okay. So now the user session is going to talk to the server session. Let me close. So we have the view, the controller, and the user service, right? And the way it logs in is that it posts. The way we've been doing it so far, right? We're just posting through an API to the server, right? Okay, now comes the good part, right? On the server service, here's a user service, right? This is where the magic happens. So on the server side, I am going to use now Passport, which has been already initialized, right? And it's already been configured to use the session, right? So here we're going to load Passport. This is the core library. We're going to load it here, And also, we're going to load the strategy, the local strategy. There it is. We're going to load the local strategy. Okay? What it does, it instantiates an object, and then it exposes this object called local strategy. And we're just keeping an instance of that object inside of the Passport local library. Okay. And here's our login. There it is, our login. Right. What's different here from our previous login? Right. Notice that it's using Express. It's listening for an incoming post to the API login. That's what we've been doing so far all along, right? And notice that it has a function that is going to handle that incoming login. Yes? So what we're going to do here is that we want to have Passport handle that. We want Passport to handle the mechanism of checking to see if we exist or not. So the way Passport works is that it provides an API, right? It provides an API, but the actual work of testing whether somebody is logged in or not, in our case, right? When we're using authentication that we provide, right? We have to write that, right? We have to go and actually see whether username and password actually exists, and then tell Passport, yes, they do exist. If this were Twitter, right, Passport provide it would ask Twitter, says, hey Twitter, these are the credentials, and Twitter would come back saying yes or no, right? This person does exist for real or not. Now, in our case, in the local strategy, we don't have anybody to ask. We don't have anyone else to ask, right? It's us. We have to implement it. If we would be asking Twitter, Twitter would have its own data model, its own database, and its own query, right? Its own internal implementation, and it would return saying yes or no, okay, or error, or some kind of error, right? So since in this to ask anybody, we have to ask ourselves, right? We have to have our own data model, our own database, right, and maintain the users in our own database, and query this user exists or not. Make sense? Right? So we need to configure Passport, right? We need to tell it how to find whether a username and password. We need to configure the local strategy. We need to configure and say, hey, here's how you find out whether this username and password works. Okay, so let's do that. So here it is. What we're doing here, notice that before we go to the login page, what we're doing here is that we're saying, I want to inject, I want Passport to intercept the invocations to my login function. Meaning, I want first Passport to take a look at the request, okay? Do its magic. If it's successful, it should let me through. If it's not successful, it should not let me through. Okay? This is the chain I was talking about earlier, right? That we can create chains, right, of several functions that can be strung together, right? And at any one step of that chain, I can decide to either continue in the chain, or I might decide to respond back to the client. Right? So what we're configuring here is that we want the local strategy to take a look at this first. Have a local strategy look at this first. Right? What is the local strategy going to do? Well, what it should do is it's going to extract the username and password from a form that has been submitted, right? That's in the request. It's going to extract these two, right? And then it's going to say, well, okay, I have the username and password. Somebody tell me whether this person exists or not, right? How can we find out whether this person exists or not? Well, we have a user model, don't we? We have a user model. We could create a user model, right? Find user by credentials. We've written this already. I believe, right? We've written that already. We query the database with username and password, and we return either one of three things, right? We throw an error because there was something went wrong with the query, right? We return an object, or that object could be null, right? Could be so either an error, a null, or an object. Error means that I don't know if you exist. I couldn't tell. Right? The database timed out. Right? I try to communicate with the database and it can't tell me. So I don't know if you're. So I'm going to assume that you don't exist yet. Right? So I'm not going to authorize you. Right? If I come back with a null, that means that I was able to authenticate you, and no, you do not exist. Right? So I'm not going to let you through. Right? Or I can give back an object. Right? So passport local is going to first look at the request, and it's going to either, if there's an error, or if I get a null that the user does not exist with that username and password, it's going to respond immediately, right, with a 403, right, saying nope, this or 401 if you get, saying unauthorized, right, you're not allowed to go through, right. If instead, or if you get a null, same thing, I'm going to respond unauthorized, right. Only if I get an object from this username and password will passport then let me through with a success, right? And then we are logged in and whatnot. Okay? Right, so we need to configure the local strategy and tell it how to find this username and password. Well, let's do that next. Okay, so let's do that. All right, so to do that, we are going to tell passport, say passport, use the local strategy. And the configuration is in this function. Okay? So this says passport, right, use a local strategy, and the configuration for that strategy is here in local strategy. Okay? And here it is. The configuration is this function right here. And this function is the glue between passport local strategy and our application. Right? It's how passport finds out whether this username and password exists. By the time we get to this function, local strategy has already parsed the request, right? Has already extracted the username and password, right? And it has the credentials that came from the request, right? It's only going to pass it to us and say, okay, I have the request, here it is. You find out whether this person exists or not using your data model and whatever, right? Use a database or XML file or whatever, right? Any which way, any mechanism, any local mechanism that you need to fulfill and tell me whether this user is valid or not. Yes? Once you find out whether this is a valid username and password, let me know. Let me know if it's valid or not by calling that function. Done. So it passes me three things. Name and password, right? And then a function that we can then use to notify and let passport know whether it was successful or not. Okay? Right? So it passes us, and it's our responsibility now to do the low-level check to see if this username and password exists. For that, we use plain old Mongoose, like just plain old Mongoose that we've been working for the last couple of weeks, right? We're going to use Mongoose. We're going to try and find a user that has these credentials, right? And it's going to come back with a promise, right? And that promise can either be resolved or rejected, right? Rejected is an error, or resolved if it's not an error. And in that resolve, the object could be null or an actual object. Yes? The three cases. Error, null, or an object. Right? So here are the two cases, whether it's an error, right, but internally it could have rejected it, or if it's resolved, we either get a user, which is an object, or that object could be null. Right? It's null if the user with username and password don't exist, or it comes back with an actual object if that user does exist. Right? The actual implementation of find user by credential is trivial. It's in the model, user model. So find user by credential is just it's just a trivial return, user model.one, right? That's going to filter by username and password. It's going to return that object. That object will either be null or an object, right? So the service is here. If it's successful, it passes as null or an object. So notice, if there was an error, we're going to notify Passport that there was an error. And we notify it by calling done. Calling done and passing the error to the function, right? This function done takes two arguments. One of the arguments, the first argument is an error if there was an error. The second argument is the user, right? The authenticated user. Okay? So if you only get an error, then we're just going to pass the error. We're not going to. There's no point in passing anybody user. We could just say error comma null. All right, that would be okay. If we get here a success, an object, or it could be null. Right, those are the only two cases here. So we check to see if it's null, right, or undefined, or right. So the user doesn't exist. So what we're going to do is that we're going to notify Passport, the local Passport implementation, that there was no error, but the user doesn't exist. Okay, and the way we do that is we say null and then false. False or not, it doesn't have to be false. Anything that is falsy. It could be a 0, it could be null, it could be whatever you choose, you need to be consistent. Or you need to be consistent. If instead the user does exist, right, it's not nothing, we return with no error. We notify Passport that there was no error, and here's the user. That's the user. So this is the authenticated user. Passport.js does the rest, right? Such as logging us in, right? Putting us in the session, sending a cookie, sending it back, putting all the headers that are needed back to the client, right? It serializes a representation of the object in the cookie so that it goes back to the client for notification that we are indeed now logged in. Okay, make sense? Now we are logged in. We exist. Okay, we exist in users. Right? Now the currently logged in user is available in the request object. Remember, in the request object now the logged in user is in the request.user. Right? Whenever we want to get a hold of the currently logged in user anywhere throughout the application, we can get a hold of the currently logged in user saying request.user. It's available to us, right? Okay, so if we say false or we say error, what Passport is going to do is it's going to break the chain off. It's not going to continue, right? It's going to respond immediately. Instead of letting us go through, remember, the login function has not been called yet, right? Right. Our login function has not been invoked yet, right? We're still in this function, right? If the user does not exist or there's an error, Passport, this function, when we call done, and we either pass an error or false for the user, either of those two cases, Passport breaks the chain and resolves with an error, right? Saying 4.1, you're unauthorized. Okay. So on the client, on the controller that's still waiting for the response to come back, right? We don't call the successful function. We call the error function is called, and the error is a 4.1 unauthorized. Okay, make sense? We do pass the user, right? We pass the user because the user does exist, right? Then the chain continues, is allowed to continue. So finally, we get to our login function, right? So our login function is way down here. So let's look at that. The login function is simple. Actually, by the time we get to the login function, you are already logged in. We don't need to do anything. Okay? You've already been added to the session. You've already been added to the cookie. And you have been already added to the request object. The request that user now contains the currently logged in user. Right? So there it is. In the login, we can retrieve the currently logged in user request.user. Okay? And in our case, we're just going to send it back to the client. Right? Once the client gets it, what it's going to do is going to extract the user information, right? And for convenience purposes, it's going to cache it in the root scope. Okay? It's going to cache it in the root scope. All right? Make sense? Everybody still with me? Now the if we're using session, right? The passport needs to store information in a cookie enough to be able to find you again next time, right? And see that it's still you, right? So one of the things that we might want to put in that cookie, right, is at least we're going to need to put the ID of the user, right? So that when the ID comes back in the cookie, we can then look you up again to see if you are truly, who you say you are, right? So that we can find you again. Right? So we need to decide. We could put anything in the cookie, right? As long as we can, once we get the cookie back, we can find at least that ID, right? That ID, so that we can look you up again in the server, right? But just like the ID, and anything that we encode in the cookie, that's going to go out to a public browser, right? That we have no control over, right? So it's dangerous, right? To put anything in the cookie because it's publicly available on the browser side. Somebody could, start reading through the cookies, right? And looking for IDs, looking for personal information in the user, right? So whatever goes back to the cookie is going to go to a public. The data that goes back to the client, right? We need to encrypt it. And to do that, the session, if you remember, had been the session. The session, we had configured it to use a secret string, right, to encrypt the cookie, right? So that only with this key could be deciphered back from the original cookie, right? So here I encoded it and I put it as hard coded in the code, right? In a real environment, you would not encode it like this, right? Because notice that my source code is publicly available on GitHub, right? Anybody can read this secret. So now anybody who has the secret, right, can use it as a key to decode my cookies, right? So you would not encode it here, right? If you remember early on in the class, I showed you how to put things in an environment variable instead, right? On Windows, you would go and create an environment variable. You would go to system properties, right, and create an environment variable and give it a value, right? And all those environment variables are then available to use through the process.env variable. Remember that, right? And we use the process env quite a bit, especially when we use OpenShift, right? We use it for what? We use it for the IP address, right? For the port, all right? For the URL of the database, the password, the username, right? For those things. So that's how OpenShift, right, gives us a very personal information to the server without making it available publicly in a repository, in a public repository. So we can use the same technique to, encode these things, right? Such things like the secret. This is used to sign the cookie, right? So that when it gets to the client, it's all gibberish, right? Nobody can make sense of that cookie and try to extract any information from that cookie. Make sense? But when the cookie comes back to the server, we have the key, and we can decipher the cookie, and then it gets deserialized again. Make sense? Right? So we need to decide what to put in the cookie and what to extract from the cookie. To do that, Passport allows you to configure serialization and deserialization. These are callback functions that interact with that mechanism of enciphering and deciphering the cookies, right? The information from and to the cookie. Okay? So serialization is what goes to the client. We decide, what to send back to the client. Serialization is when it comes back to us, already deserialized. Okay? So we can configure and provide the callback functions that will be called every time a response goes back to the client and a request comes back from the client, right? Sending the cookie and then receiving the cookie back. Okay? Right? So those two functions are down here. So in the serialization, in the serializer, the way it works is that it passes us the current user object, right? The current user object, and then it gives us a function to call back to Passport and tell it what information do we want to put in that cookie. Right? We can pass along done and an error, there's no error, and then an object that we want to serialize and put in that cookie. We're serializing the entire user object. It doesn't have to be the entire user object, right? It has to at least have the ID, right? Because when the cookie comes back, we want to extract that ID so that we can reload the user from the database, right? And check to see that that user does exist. Okay. So here we are calling back Passport and saying, hey, Passport, I want to serialize this user object, right? And put that in the cookie, right? So that next time, in the next request, when the request comes back, okay, active from the cookie, already deserialized, here it is, right? And then we do whatever we want with it. What do? We know that that object internally had a property ID. We look them up to see if they exist. They might have unregistered. They might have been removed since the last time they logged in or something, right? Well, something might have happened. Okay, and if we find a user, we notify again Passport that yes, the user still exists. This user is still good. This ID of the user is still good. This user does exist. All right. Or if there's an error, right, we notify with an error. Okay, make sense? All right. Okay, so that's login. That's login. So when it gets back to the controller, we get a response, and that response, actually, we should have added. We should have said if, right, because the user isn't the data. That user, well, actually, no, that's fine, right, because the data could be null, right, and that's fine because we are storing it in the root scope current user, and that would nullify the current user. That actually it's perfect. Right, if it's null, it nullifies the current user in the root scope. If it's not null and there's an actual object, it gets set over here. Okay, and then we navigate to the profile. Okay, all right. So once once we are in the profile, we could decide to log out, right? And say, okay, so I no longer want to be logged in, right? So to implement that, in the index page, I believe, is it the navigation? Oh no, yeah, in the index page. In the index page, we have a logout button that, when it's clicked, is going to be handled by this navigation controller, just the logout, right? And it's going to use the user service to is that it's going to post, right, an API logout. Right? It's going to post to the web service, which is implemented here, right? We have the logout. Notice that the logout is not protected by anything, right? Meaning anybody can call this post. That's okay. Right? It's not dangerous. Anybody can log out. We're not going to stop anybody from logging out, right? And so there is no middleware in between the logout. It's not protected by anything. And in the logout, it's as simple as calling the logout function on the request. That's a function that was added by Passport API when you initialize it, right? It adds these additional functions to the request, right? So that you can easily just log out. What's going to happen? In the local strategy, it'll clear the session, right? But it might do different things for Google or Twitter or Facebook, right? Each strategy will be handled differently, but they're all, the details are hidden from us because we can just call this function .logout. Yes? If instead we knew that our particular strategy uses a session, then we might be tempted, right, to just clear the session, right? But don't do that, right? Instead, use this high-level logout function, which will work for all strategies. Make sense? All right. So yeah, so log out, and then we sent back a 200 saying, yes, we were successful at logging you out. Okay. All right, so let's look at registering. So I'm a new user, and I want to register. And to do that, we have here a user and username and password and so on and so forth, and we call the register user on the controller. And the controller uses the user service to register, and it passes a user object. Okay, so all of this you've client sends a through, wait a minute, was it? Or register, the register function, and the register function is right here, register. And it calls API register. Yes? Right? Okay, so on the web service, we have register, also unprotected. Anybody should be able to register. Right? I'm not going to challenge you, right, if you try to register, right? I'm going to challenge you if the registration failed, something went wrong, I wasn't able to register somehow, right? So in the register function, right? Well, one of the things we're going to do in the register function is that we, in the data model for each user, we have a attribute called roles, right, which is an array of strings, right? And these strings represent the roles that the user is in, right? It can be many roles. Okay. Now, when people register, they shouldn't be allowed to choose the role that they're in. Okay. Whereas if an admin creates the user, the admin should be allowed to create the roles that the user is in. Yes? So both of them are inserts of user instances in the same collection, right? But we have two ways of getting to that, right? if it comes from a registration page, we are going to make sure that the roles is determined by our business logic. Yes? If it's an admin, if it comes from an admin creating a user, then it's determined by the admin. Correct? So here we are extracting the user from the body, right? And we are ignoring any roles in the incoming JSON object, right? Because somebody might have posted this, not through our registration page, but they might have posted it from using Poster, right? Poster is a tool that allows you to manually send posts and deletes and gets and puts, right, to any URL, right? You can just send any JSON to any URL, right? And somebody might have posted a user object, or somebody might have sniffed our request, right, and see that whenever I register, this is the JSON that goes out to you. And when it comes back with roles, I see that there's an array of roles. Let me try and post an array, right, to this URL. Let me try and post a roles array, and I'm going to put in there admin as a string, right? And so maybe that works, right? But here we are thwarting that by overriding any roles object that might come in the JSON object, right? Even if it's not there, I don't care. I'm going to override it, dot roles, and I'm going to give you a default role, right? So anybody who registers through the page, right, through the registration page, is automatically the student's role, okay? And they can't do anything about it, right? They can't change their roles, but only an admin could change their roles. Make sense? Right? Okay, so I have the new user with the roles hard-coded to student. Now we're going to check to see if the user already exists, right? If the user already exists, I'm going to abort the registration process, right? If the user doesn't exist, then I will go ahead and create the user. Okay? So first, we'll check to see find user by username, and that's a trivial model implementation. Right, so find user by username is just a find one, right? Username, right? Just a return. So that's easy. So on this, when it comes back from the user finding the user, this user object will either be null if the user doesn't exist, right? In that case, I will create the user, or it could be an object, right? If it's an object, then I cannot create the user object, right? I'm not going to continue and do the insert. I'm just going to respond immediately and say, sorry, that username is already taken, right? So what we're going to do is that if the user does exist, I'm going to respond immediately, right, with a null, right? So the client is expecting a user, an object that represents the brand new user that was just created, right? If it gets an object, it says, yes, I was able to register, right, with that username, with that password, and I got the object that represents that new user, okay? If instead it gets a null, it's going to interpret that as it was unsuccessful. I didn't get back an object, okay? So if instead the user does not exist, I'm going to continue with the registration process, right? I'm going to go back to the user model and says, okay, now that I know the user does not exist, create it. Go ahead and create it. Okay. So this one says, create the user with a new user, which is create user is just here, right? It's just user model.create. You get the user object that you pass in, and then it returns. It returns with the brand new user having been created, right? Having been inserted. right? That's the document that represents the brand new user, right? So I'm going to do some validation and make sure that indeed the user is valid, right? The user exists, right? It's not null or undefined, right? Somehow, and if it's not null or undefined, I'm going to notify Passport that this is now the currently logged in user created. I just inserted in the database represents the latest person who's logged in. Okay. To do that, we use another function added by Passport. You know, we've seen already a couple, right? Request.user, it was added by Passport. Request.logout was also added by Passport. Now here's a request.login, right? It's a high-level function provided by Passport where you provide the user object, right? And now Passport does its magic, right? It serializes the object, it adds it to the session, right? It creates all the headers for the cookies, right? It encrypts that. It does all that magic for us. We don't need to do any of that, right? It's all hidden by this login function. And then the second argument is a callback. It's a callback where it provides either an error or no error, right? If there's no error, we're done. We have the user. We have the user successfully logged in, and we're just going to send it back to the client, right? And the client, remember, the client can either receive an error because we send an error, right? Because of the status error, either a null because the user already existed, or this object because the user didn't exist and we were able to add it. And not only do we add it, right? It is the currently logged in user. Currently logged in user. It is now available everywhere through request.user. Okay, it's available everywhere. And we respond. Okay, so now we're registered, and depending on the roles that we get back, right? We register. Remember the roles. The default roles is students. Right? So register. We're not going to see the admin link, right? We're not going to see. We will see the profile link and the logout link, right? That is implemented in the index page, right? Where we use the current user in the root scope, right, as a convenience object, right, to turn on and off certain sections of the links, right, which we looked at a couple weeks ago, right? We did that already. But notice that the admin link is not available unless the current user's role contains admin. Okay. This is on the client side, right? On the client side, we have this link, right, that is hidden from you, but a savvy developer can read this, right, and look at the HTML and says, oh, there is a path that would allow me to go to the admin page, right? Remember that the admin page, right, all the client side needs to be supported by a server side implementation, right? So even if they try to go to the admin, even if they get to the admin page somehow, right? Even if they try to send, try to remove or update users, right? We always have to support this on the server side, checking to see end user. Even if they were able to send a valid request, we have to compare them against their roles, right? When we and look them up in the database and check to see if they're allowed to do what they say that the request went through. Okay, so to do that, right? If you remember, we had implemented several resolves, right, on the client side. right, that protected certain sections of the application, right, from navigating to and fro various parts of the application. And the way this worked was that any intention of the user to navigate to a certain path was intercepted by one of these resolves, right? It says, if you try to go to the home page, or if you try to go to a profile page or the admin page, right, we're going to intercept those intentions and first invoke these functions and see what they say, right? If they resolve and say everything's okay, I'm going to let you through, right? I'm going to let you go through that page. If they reject your request, then I'm not going to let you through and go to that page, right? And notice that there's a couple of implementations here for the admin page. Oops, we're checking to see if not only are they logged in, right? Are they in the admin role? In the profile, we need to verify that you are logged in. And for the home page, we want to know whether somebody's logged in, right? We don't care about their roles and we're not going to thwart you from navigating to that page, but we want to know who's logged in so we can show maybe some customized content, right? So let's quickly look at this again. They are all implemented down below as functions, and they all use the API logged in URL API. Okay, they all go to this URL API to check to see who's logged in, if anybody. Okay, so let's look at that. So say I want to go to the profile, right? So I log out, right? I'm logged out and I try to go to the profile. I'm not allowed, right? So here's what I type. This is exactly what I typed, right? And the way this works is that normally you would go, the controller would be instantiated, right? And you would be navigated to the profile view. That's a normal flow. But we have declared or resolved, right, to first call this function here and see what this function has to say about you trying to navigate to that page. So that function down below, check logged in, what it does is that it's going to go out to the server, right? It's going to go out to the server and see what right? So logged in is implemented here on the service server, logged in. There it is, logged in. Logged in is very easy. All right, logged in, the only thing that it does is that it checks whether you have already been authenticated. If you have already been authenticated, it returns that object, right, in the request, right, in the session, right? It returns that object and serializes it back to the client, right? If you have not been authenticated, it's going to return a flag, right, or some identification saying that this person doesn't exist, right? This person has not been authenticated, right? It either returns the request that user, right, that is a currently logged in user, or a 0. Okay, and that's exactly what the response that comes back, right? We check to see if it is a 0. Sorry, if it's not a 0, meaning it's an object, then yes, you are logged in, right? You are logged in. We're going to update our root scope, right? Again, just to cache locally and turn on and off certain links, right? And we're going to resolve. Resolve means that whatever your initial intention was, we agree with it. It's okay. Where is that you wanted to go? Oh, the profile page? Go ahead. Go there. Right? I don't really care where you were going, right? I was only asked whether you were logged in or not, right? And I'm going to vote yes. Wherever you wanted to go, I'll let you through. So any page we want to protect, you can just put that resolve, right? Notice that it's implemented in a single place, right? And then we can attach this behavior of checking to any page you want to protect, right, by adding that resolve. If instead the user is equal to 0, we're going to reject the promise, right? And we're not going to let you through. Okay? And instead, we're going to kick you back to the login page, right? So there's a couple of other pages. The admin page, we try to navigate to the admin page, we're going to call check admin. Right, so check admin, not only check admin, where's check admin? Right, so not only is it not equal to 0, right? It also has to have that the user is in the admin role, right? If it is in the admin role, we're going to resolve, right? Notice that it should have also the reject part of this, which it did implement, right? But in the reject side, we could send them back to login page, just like we did for the check logged in, right? We could kick them back to the login page. And finally, we have one last one, like the home page, right? Where we don't want to stop you from going to the home page. We're not protecting the home page like we're protecting the admin or the profile page. What we want to do is that page, right, we might want to display some personal information or some customized information that is based on the user, right? That means that we need to load the state information about that user, right? And to do that, we're going to use this function, check current user, that is going to get same thing, get logged in, but what it does is that it uses that object to update the current scope, right? But it's not going to stop you from going there. It's not going to reject, right? It's always going to resolve. It's always going to resolve, meaning you can always go to the home page. You get there, the current user might be null, or it might be a real user, right? And depending on whether you have a user or not, you might display, welcome pages, or maybe you're redirected to your profile because I know who you are. If I didn't know who you are, then you go to the generic homepage, right? That's very common, right? In social network applications, right? So here, if it's not 0, then we set the current user. But regardless, we're always going to resolve and let you go to the home page. Okay. All right. So if we are in the admin page, if we are an admin and we are allowed to go to the admin page, right? In the admin page, we're going to want to load information about all the users. So when we initialize a page, the first thing that we're going to do is load all the information about that I can administer, right? In particular, I can administer other users. I can create other users. I can remove user information. Okay. And here we're, by the time we get to this controller, we have already been authenticated. We already know that we are in the admin role, right? And I can start sending these commands back to the server. Give me all the users. But again, we could, a savvy JavaScript developer, right, might thwart the code to or the browser into letting it come to this page, right, and calling these posts and gets and puts programmatically, right. We have to validate request that goes to the server to validate that it still is valid. Okay. So this find all users, right? If we go in there in the service, okay, find all users, it's just going to do a get API user. Get API user. On the server side,
get all users or find all users. This one, API, get API user. There it is, right? And we would normally just go to find all users, right? And do a model.find, right? To retrieve all the users. But you'll notice that we are prefixing it. We are injecting here something that will validate whether we are authenticated, right? In this particular case, we are using a function that, just like we did earlier, and we declared a function that needs to be called to do some manipulation of the request, right? In this case, it was using the local strategies middleware that extracted a username and password from the request. Here, we're implementing our own. And auth here, right, is implemented by a function down below. And this function is basically going to check the request, right? It's going to validate that you are authenticated, right? And to do that very easily, notice that Passport gives us a very convenient function that we can call it, has this person ever been authenticated, right? Is the cookie that came along with the request, is it a valid cookie, right? Is it in the session? Has it timed out yet, right? If it hasn't timed out, then we're all good, right? This person has been authenticated. So here, if they haven't been authenticated, we're going to not let you go to find all users. Right? We're going to break the chain. Right? We're not going to let you go through find all users. We're going to immediately respond with an error. For what? Right? It is unauthorized. You haven't been authenticated. Right? Remember, because these URL, just like the pages that you navigate, are publicly available. Anybody can post and put and get, right, and send deletes, right, using tools, programming tools, right? So if you ever get here, we're going to authenticate you on the server side, right? So if you are indeed authenticated, we're going to say next. That means we were the first, right, measure of security that came in the request. Authenticated you says, yes, you are authenticated, right? If you weren't, we're going to respond with an error 4.1. If not, we're going to let you through where you were trying to go to. Where is it you were trying to go to? I don't know. So I'm just going to say next. Right? Do that. That's a callback function that Express gives us, right? To continue in the chain, right? And what was next in the chain? It was the function the find all. This is the next one in the chain, right? Find all users was next in the chain. So we let you through only if you're authenticated, right? But that's not enough, right? It's not enough, right? Find all users is going to do an additional check. It's going to do an additional check, right? It's going to check if the current user who's logged in is an admin, right? We could have done that also in the filter, right? We could have done two filters, one called off and the other called maybe admin, right? The off one is whether you're authenticated. The filter admin, right, could have done both, right? Authenticated and check whether the user in the request had the admin role, right? But here, I split it off in this other way. So it takes out the user from the request, and in admin, it takes that user and checks to see if the role of the current user has the admin. Okay? And returns true or false. So find all users checks to see if you're an admin. If you are indeed, I will then call find all users, right? In the model, which is just a user model.find, right? That's all it is, right? And if it's successful, I'm going to return all the users. Otherwise, is an error. Okay. If you're not an admin, I'm going to return a 403, right? One is 4.1, I believe, is you're not authenticated, whereas 403 is unauthorized, meaning I know who you are, you just can't do that. what you just tried to do, right? It's a different error message, right? Okay, so that's one of them. And let's take a quick break, and then we'll complete this when we come back from messages.
Professor, on MongoDB, so when you're running it locally, right? So you create a database temporarily and then just give that as the name in your local host, colon port number slash.
You don't have to create it
Locally.
locally. Yeah, just by connecting to it, it creates it. If it's not there, it'll create it. If it's already there, it'll just use it.
Okay.
Yeah, you don't need to create it.
So and now remotely when we use it on OpenShift, it is going to be only one database, right?
Yeah, it's
The
that
app
one
name.
database.
Yeah. So all our tables, even our project tables and our assign tables.
Yes, just like locally. Locally, you're just using one database, right?
Like locally, you can have multiple databases. Like
Right. Yes, right.
But
Yeah,
remotely-
locally, you have any number, and remotely, there's only one.
one database.
Yeah, that's why I asked you to prepend your
project.
collections with assignment dot whatever or project dot whatever, because it's only one database remotely.
Remotely, there's only
Yeah,
one.
locally, you didn't have any number.
And schema will be your table, right? Technically, the template for your table is
It's
schema.
yes, yeah.
But,
When you say collection,
yeah.
and the name that would be the name of the collection, the table.
Yeah, and when you create a model on Mongoose, right?
Yeah.
So you give a user in quotes and then say comma and then mention the schema that you want to copy it into, right?
Wait, say again?
So when you say mongoose.model of and say the model name in quotes and then say comma and then provide the schema
Yes.
that you want
Yes.
to be structured as. So the one in quotes that you mentioned, what is that actually?
So Mongoose keeps track. That's how Mongoose keeps track that schema has been already compiled. So that if you try to create another model with the same name, it'll stop you. It says no, that schema has already been compiled.
Okay.
So that's a unique string that it uses to keep track.
So we are not going to use it anyway.
No,
Okay.
doesn't
It's
matter.
just Mongoose is internal.
It would use it if you didn't provide the collection in the schema.
Okay.
It would use that string for the name of the collection.
Okay. Like
Yeah,
you said,
you use
like
that,
we
yeah.
override that and.
Yeah, I don't like that name that it chooses.
But anyways, we have named. We also have rights to name that there as well, right? So you
Where?
can still give your name in that quotes.
Well, no, the thing is that it takes that and it pluralizes it.
So it makes it user.
Yeah, so
you can override that.
Yeah, I don't like that. So I want to have total control of what the collection is called. I don't want it for it to choose names for me.
So technically, you don't create database. You just boot up the Mongo server and then
when it connects
referring to that will.
Yep.
Okay. But
Actually, it doesn't actually create it until you insert.
Oh, technically. Okay.
Yeah, not until it insert does the database.
So and every time you create a schema and you make a template model out of it, that's when your actual table gets created and
when you insert
into that
yes.
table.
Yeah.
Oh, okay. Okay. All right. But remotely, it's the same database always.
Yeah.
Okay.
That's on the free plan. On the free plan, you only have one database. But if you go into the paid plan, you can have any number of databases.
But remotely, you don't have any access to see the query
No,
or anything.
no.
Right?
Well, there's a client. You can install a client.
OpenShift Mongo client.
Yes.
Okay.
I think it's called Rock Mongo. So, but it would be a separate gear. So you had the Node.js would be a gear, MongoDB, and then Rock Mongo would be another gear.
Just to see what's happening on that.
Yeah, and you can use that to query and you can see the data. It's a.
But all these are like persistent, right? So once you create a login and you're so every time here you don't have preset data like we used to have in JSON. There's no preset data, right? So every time you have to register all the users.
Yeah, it's whatever.
Make profiles for them.
Yeah.
And once the server restarts again, everything is gone. No, right?
No, it's there.
It's there. Right?
Yeah.
Until I delete.
Yeah.
Mm-hmm. Thank you so much. Thank you.
Yeah, I have a good question regarding my API that I'm using for the project.
Okay.
So it's not giving data for all the instances. So maybe I'm using a sports API which gives details about a team or a driver. So it's supposed to give data from like 1951 when the sports started. But for many of the years they don't have few link data and points in it. So if I have to validate it, like when I make an API call and I get a JSON list. So should I do it on the controller side, or is it good if I make a call from the server side and process it there? Like, is there any advantage?
So the API is, where is the API being invoked
So
from?
right
the
now-
client or the server?
Yeah, so right now I'm doing it from client because the way I'm trying to do it is I just get data from the client, and the client the user can choose what data he wants to store on the server side, like for himself to view later on. So that data, when he clicks, okay, I want to store this particular fact. It will go back to the server and that's stored on the in the JSON format for him.
Okay.
But now that I see it on the client side, sometimes the data is missing or it's not complete.
When you say on the client side,
Yeah.
you're saying
So when I make a call through the controller, using the service, so I've written a service for the API, and I make a service. I get a JSON list. Sometimes the few data objects.
why is it sometimes missing? It's because of the API or because of
No, because
because of the API. Okay.
So sort of validation.
Yeah.
So like, is it good if I do it on the? Like, will it be heavy if I do it on the client side? Or?
So on the client side, you can do light, very light validation. right?
Okay.
Like for instance, you can't do any validation on things related to other things. You can't do
Right.
that, right? You need to do that on the server. But on the client, you could do, whether dates are in a particular range.
Right.
You can do some light regular expression checks to see that things have a particular regular expression. Whether things that are required are missing, things like that.
I think
it's very, very light.
Yeah.
But on the server, you should do some heavyweight validation, right?
Okay.
Mongoose already does validation for the data typing, right?
Okay.
So that you don't need to do, right?
Right.
Mongoose will handle that. But things that are related to one another, right? That if this user is removed, then I also have to remove those things, or those kinds of things. Those are server side.
Okay.
All those are heavyweight server side
Okay.
validations.
So I think most of my validations will be lightweight.
Yeah.
And also, like, another question was, so the initial requirement for me was get a sort of fact from the API and create a question for a quiz.
Mhm.
But because like, the objects that I'm getting are of different types, let's say the schema is different for each, the driver or the user. Stuff like that. So can I just sort of tweak it a little bit and have a preset format so that the functionality will not be like, okay, user can make a quiz out of any fact. It's just a few facts that he can make a quiz out of. Will that be okay, or will I
think so.
will I have to redo the proposal part and get it validated?
No, don't redo anything. Always
Okay.
keep the same proposal.
Right.
If there are any changes, just document them in your
Okay. Okay.
and why you're changing it, or what's your criteria for changing it.
Okay. Okay.
How you think this is not breaking the overall requirements,
Yeah.
right, of relationships.
Yeah, like more than 2 users will still be interacting.
Yeah,
It's
but
just
as long as you
interact.
maintain the basic requirements,
Right. Okay.
you can do whatever you want.
Okay.
Right.
Right. Thank you.
All right. Yes.
An assignment that you have to submit. There is a form symbol JSON data, right? In that there is a fields data.
Mhm.
They also have an ID.
Yes.
So how do you recommend to change their ID using the data? Because form data has a user ID also.
Yes.
Yeah. So we are hard coding it by getting from the MongoDB.
Okay.
Because we cannot get by any other means.
Wait a minute. Okay, so which ID are you talking about? The underscore ID or the user?
Yeah,
ID?
the underscore ID. First of all, talking about the fields underscore ID.
Yeah. Okay. What about those?
The fields or underscore ID need to be set first of all.
No. All the underscore IDs on Mongo, they're created for you. You don't create
But
those.
when we create the form,
When
the
you
fields
create-
would be empty, right?
When you create the form, well, yes.
Right. So fields would not have any data in it,
You're right. It will be an empty array.
right? So
Yeah.
when I'm creating a field,
Yes.
I need to create a new field JSON data, I guess.
Yeah, you would create a new instance of a field, right? And then you would push it on the array, right?
Okay.
So the field object comes from the JSON field object comes from the client, right?
Okay.
That represents the type of the field,
Yeah, right.
all that stuff, right? And that object, unmodified, right, untouched,
Okay.
you would just push it into the fields array of the form. So you would first fetch the form by ID,
Okay.
say, and then once you have the form by ID, you would say, dot fields, dot push,
And
and then the object gets added. That will create an underscore ID and then you save the form. You save the form.save, and the new element gets inserted in the database, right? In that array, a new ID gets created for the field. And you don't have to manage that ID.
But just now the form.mock.json that we have, they contain underscore IDs.
Yes.
So we should just delete all of them just now?
Yeah, when you go to the database assignments, you're not using the mock data anymore.
We just
You
create
throw
our
away-
own.
Yeah, you throw away the
just
mock data.
to check, just create our own data.
Yeah, it's completely blank.
Okay, so
It starts off completely blank.
Okay, so we can do anything.
Yes.
Okay.
Yeah.
And about the user ID.
Yeah.
Now user
In the
ID.
form.
Yeah, user ID we directly hard coding it as 1, 2, 3 for the LS.
Well, not hard coding it. It would be D of the currently logged in user,
Oh.
right? It has to be whoever created it,
Okay.
right? So when you create the new form,
Okay, but actually we were using the mock JSON data.
that doesn't
Okay,
exist
so
anymore.
that's a,
Yeah,
we
doesn't
just
exist
have to
anymore.
start from scratch.
Yes.
All the data.
Yeah, the mock is gone. All the mock is
Okay,
gone.
everything we have to done from scratch.
Yes. All right, let's keep going. All right. Okay, so find all users. So, please come on. Let's finish this up. So this find all users is the first thing that an admin sees, right? It sees they see all the users, right? And they get rendered as a table on the admin page. Okay, and once they're in the admin page, the admin can start manipulating the users, right? They can remove the user, they can edit the user, they can create a brand new user. Okay? So let's look at one of the simple ones, which is deleting a user, right? So the view, the register view, the admin view, they're going to take the list of users, and they're going to iterate and display the ID, username, first name, last name, whatnot, everything, right? And at the end is going to have two buttons, one to remove the user and one for selecting the user. For the removal, that's in the client is going to generate a delete. Here's a delete, right? It generates a delete passing the ID of the user that I want to remove. It's not me. It's not my ID. Well, I guess I might remove myself. I am listed in the admin, right? The list of all users, I guess. Perhaps we might want to check this, right? If it's the same user who's removing the curly element that is being removed, perhaps we might stop them and don't allow that, right, as a use case. Anyway, so this is handled on the server with this delete over here. Okay? Please. So with this delete over here, and notice that again we are intercepting this with an auth, right? Checking to see if the person is logged in, right? So if we go to delete, we first check again if the current user is admin, right? We retrieve the ID of the user that we're trying to remove, right? One check, I guess we should check, right? Whether the ID, my ID of the currently logged in user is the same ID of the person I'm trying to remove, I might stop and not do this. Okay, so we don't support the use case where somebody can remove themselves. Okay, then if it's successful, right? And well, this is not a user. Actually, this would return a status, right? This one's going to find all the users again and return all the users. So that's why when we remove, right, it refreshes and displays the remaining users. Okay. What about updating a user? So updating a user, if we click on update on the admin view, we select the user, and when we select the user, that user is copied to the top level form at the top. So just like this, right? So if I log in as Alice, I go admin, I can choose someone. I can choose Bob, and it gets copied at the form at the top. So I can manipulate Bob. Okay, and when I say okay, a put is generated. So here's a put somewhere. Update user generates a put and says this is the ID of the user that I am updating, and here is the user, the new user, including any roles, right? Any roles that I might have added, I can add other roles here, right? So in the update on the server side, we receive the put right here. Again, we're going to check whether you're authenticated, right? And in the update user,
we're going to retrieve the new user from the body, right? And if you remember, this update user can be called from two different places. It can be called from my profile page, and I'm updating myself, or it can be called from this admin page, right? And it needs to behave differently depending on where it's being called from, right? Or who's currently logged in, right? So first, we check to see, are we admin? If we are admin, if we're not admin, right, what it says there, if we're not admin, we're going to ignore any roles coming in from the client. Now, somebody might have injected, right, might have sent a put and might have injected the roles there and tried to create themselves with admin roles, right, so that they can then log in as admin. Right? So we're going to thwart that. If the currently logged in user is not an admin, we're going to remove all the roles. Okay, we remove all the roles so that they're not going to be updated in the database. Right, the database when you do the $set, okay, it ignores any fields that are not in the JSON object. Right, they're not modified. Right, they're left as they were. Okay, if instead you are okay, we'll remove the roles. So by the time we get here, we can check to see the roles object, right? If we removed it, it's going to be of type undefined, right? So it's not going to go in here. If instead it has been removed, that means we are an admin, right? Roles have not been removed. It comes to us as a string, right? Because it's an input field, right? It's just a plain old input field. Right? But that input field is comma separated, right? The string in there is comma separated. So what we're going to do is that we're going to split that string on the comma, and then we're going to put it back in the roles field, right? Ready to be updated in the database. Make sense? The database is always stored as an array. When it goes back to the client, it's an array. But when it gets rendered on the input field, it's a string. So that when it gets sent back to us, it's a string. So we have to convert it back into an array, so that when it goes back, it's an array, and then it goes back to the string. Make sense? Right, so you have this conversion, these different representations, how it's represented on the UI, and how it's represented in the database. Right? You have to make sure that we always do this conversion. Right? So in the data model, we say which user we're updating and the new user data, including the roles. Okay. So in the model, in the user model, we have the update, and the update is fairly simple, right? We just say user model update. We provide the predicate, to identify the exact user that we are updating, and then we use $set. And $set takes a user object, and any fields that are in that JSON object will be updated with the new values of that JSON object. If the field is not there, it will ignore the field. Okay? If you already had a value, it'll leave it alone. If the field didn't even exist, it will still not exist. Right? It'll just ignores any fields that are not in the JSON. Right? And then we just return all the users back to the admin. Right? So yeah, so we did delete, we did update, we just have to do create. So in the create, right, it's invoked by creating this plus here, So this is different from registering. See that? So there's two ways that a user can be added to the database, right? Either people register themselves, right, and they're created, and we make sure that the role is always just student, or we create you right here by adding you. An admin creates you, and if an admin creates you, they can give you whatever roles they want. Right? So there's two separate paths.
It uses the same user model, but two separate ways of getting to the server, right? So in the in here in the client, right, the create user and the register user, see that? It has two separate ways of getting to the server. This one is a post API user, right? Very RESTful, right? Whereas this one, register, is not RESTful, right? It's more action based. You know, what is it you're trying to do? You're trying to register, right? Where the other one is I'm trying to post a new instance to this collection of users, right? So they enter to the web service in two different ways, right? So for registering, they come in through here, and it's not protected. Anybody can register. See that? It's not protected. Anybody can register. We're just going to check to see that user already exists and all that, right? And we're going to validate and make sure that you are in the student role when you first are inserted. Whereas if you instead come in through create user, that one is protected. Not anybody can just create a user, right? It's a little bit different. First, we're going to authenticate you and make sure that you are logged in, and that and we should have checked to see if you're an admin too. Okay. Over here as well, just like we did in the other ones, right? We should have checked to see that you are an admin. If you are an admin, I'm going to grab the user, okay? And we're going to check to see if you have a roles that was passed in from the form, right? You might have passed in just an empty string, right? You know, the admin might have not even sent any roles, right? They just left it up. They just left it blank. Right? They didn't provide any roles, right? Or they can provide roles. So here's where we check to see if there are no roles. We're going to initialize them to be the student, right? That's going to be their default roles, right? If instead they did provide roles, right? And I have at least one. I have at least two roles, right? I'm going to split, and I'm going to split it, and the array and into the roles array. Okay, so I'm going to create an array out of the array the roles, that string that comes in, right? And then everything else is the same, right? I'm going to check to see if the user exists. If the user doesn't exist, I will create the user, right? And if I create the user, I'm done. I'm just going to just return the all users. Notice that I'm not logging in this user. See that? In register, when we created ourselves, right? We were now the logged in user, right? Here we're not, right? We're just inserting this brand new user into the database, but we're not logging them in, right? The admin is the one who's logged in, not the user we just created. Make sense? Right? So yeah, so these two implementations are different. They both insert a new instance of a user into the same exact collection, right? But they both have different business logic, right? One is anybody can register and they're not logged in with a default default student role. The other one is invoked by an admin, right? Who can set different roles for you, but you're not logged in, right? That user is not logged in. It's just been added to the database. Okay. All right. I think that's it. We did delete. We did create. We did the list all the users. We did an update. What else is there? I think that's it. All right. I think that completes our sample main passport application. Please feel free to use it for the new assignment that's coming out this week. That will be the passport assignment. That will basically, what it asks you to do is to take the current assignment that you've been working throughout the semester and now add Passport.js support, okay, and user management. It also asks you to implement that final admin page that we've been, we haven't done anything with that admin page yet, right? But now that we have talked about user management and how to work at it, please make use of this so that with ideas on how would you go about implementing that. All right. Also, please feel free to use this for your project. Right. All projects should support user management. Logging in and each user having their own set of data and their own relationships with their own data models. Right. So again, please use this. This should be a starting point that you can then build on and add your own features. Okay. All right. So last week I introduced you to a new application that I've been working on for creating online phone-based applications. Right. So what I did is after having created this mean stack example, and now that I've asked you to go ahead and refactor your own projects and your own assignments using this as an example, well, I did it myself. I went back and refactored my application, my web app maker application, and I added user management and logging in and using Passport.js. Okay, so I'd like to demo for you where I am right now and see what I had to do to refactor my application. So let me stop this and load that application now. And I'm going to restart it, and I'm going to load it here. Okay, so if you remember, this used to go directly into the list of developers, right? All right, so and that that was fine as a prototype, right? That I should be able to somehow choose some developer. Once I choose a developer, I should be able to look at that developer's relationship with other domain objects, right? And that allowed me to navigate all throughout the data model. But I since have added support for Passport, and each user as they log in, they should have a different experience, right? And they interacting with their own objects. So let me show you here now. Also, this application, unlike the OMDB application that we looked at a couple weeks ago, that one was open to everybody, right? It had a public set of pages that anybody could go and visit, right? Everybody could go to the home page. Everybody could go to the search page and search anything they wanted. They could navigate to the details page, right? You need to log in to use, a lot of the application without logging in. Yes. Only when we needed to know who you were, we then challenged you, right, for your identity. Yes. Whereas this application is a little bit different. It doesn't have a public place, right? It doesn't have a public homepage or search or details that anybody can use, right? This one is specifically tailored for people that I need to know who you are, right? And once I know who you are, then I'll let you and peruse through the application through your own piece of data. Okay, so let me log in as Alice. Once I log in, notice that it kicks me to the profile page, right? And this is a mobile-friendly profile page. Notice that I don't have access to the list of developers, right? I shouldn't have access to a list of developers. Only an admin user should have access to a list of developers. I'm not an admin, in my profile page, I can see some of my personal information, right? And also notice that at the top and the bottom, there's a fixed footer and header, right? Very common in phone applications, right? That there's a scrollable part, and you have a top header that is always there for you to manipulate some of the information that is being displayed, and then at the bottom you have links that are very generic that let you navigate to different portions of the application. Okay, so you also I've styled it a little bit so that it looks a little bit more professional. You also have a logout, right here in the profile, only available here, or it could also be available, at the bottom of the footer if I want to provide the capability of logging out from anywhere. Although instead, what I did is I added this link at the bottom with a home link that, as I navigate through the page, through the various pages, this home link can always bring me back to my profile page, the starting point, right, where I can log out and change profiles and change preferences and things like that. Brings me back to a centralized place. Right? I chose a profile, but it could be anything else. Okay. I don't have yet a drop-down menu. I didn't see the need for it just yet, but I might add it a little later. Now the navigation to my page, to my applications, is through a dedicated button that navigates me to my applications. If I log in as someone else, I'll see somebody, that person's applications, right? So if I click on an application, I have just one application here. I simplify the buttons so that they don't look like buttons, or they look like links. I thought this was a little more professional looking. Also, instead of for editing purposes, I'm using the cog or the gears, right? That allows me to go and modify that application, right? I made it look just a little bit prettier. Also, I added this cancel that allows me to just cancel and go back. But I'm thinking maybe the arrow going back was a little better. I don't know. Anyway, let's see. I can add other applications. So I can say app 2. Say OK, and then it goes back to my list of applications. Or I can click on the application itself and navigate to the pages for that application. Right? And in here, I can add various pages. So I can add maybe a home page. I can add maybe blog post. Okay, and then obviously I can modify them and go back and edit, and then cancel. In the blog post, right, I can add all sorts of widgets, right, as we saw earlier. If we click on widgets, I can choose a header, right? And this was the default content. I changed the cog here to show that I can edit it, so I can now go into an editor for this particular widget, right? Since this is the title, all fields have a common set of features such as name. Everything can be named. All elements all widgets can have a name, a text attribute, right? But different widgets have different other attributes, such as header has this additional attribute of size, right? So I can choose the size of my header. So I can choose a text to say blog posts, and the size is 2, and I can say OK, and it goes back and change the size and the text. I can, just to show you that the size, I can change it to be really, really small. It's OK, and it's really, really small blog posts, right? Let me get it back to maybe a 3. It's OK. I added other things, other elements that can be also edited. I can say I can add a label. So, for instance, a blog post can have maybe a title. And then I can have maybe an input field.
and that input field can have a placeholder. I can say that this is title and no text. There it is. So it has a placeholder, and somebody can type something in there. And then I can have another label and say that that's the body of the body of the post. You say okay. And then I can add another one here, another text input field. But in this one, I can configure, and this is I can remove the text and the placeholder. I can say body, and the rows I can say I want 5 rows. And for that, it creates a type. Right? Then I can add maybe a button at the bottom that allows me to. I can change this, and the text can say maybe post, right? And I can style it, say that I want it to be primary, and say okay. And at the bottom, I have a post, right? So this would allow me to create a post page with for a blogging application, right? That somebody navigates to the blog post page, right? And as they click and post something, they would be added to some database, right? That I need to do just yet. I'm not there yet. I'll add that maybe this weekend. Okay, so I've added also a couple of other things. And for instance, I've added ways to add, for instance, galleries of images and galleries of YouTube videos, right? Some of you are working with YouTube videos that you want to embed in your applications, right? So I've added this as an example, and you're welcome to look at how I did it. So a new page, this might be a video gallery page, right? Oh no, wait, it's okay. And in here, I can go in and put here a header and say that these are YouTube videos, size 3. It's okay. And then I can add YouTube videos. I can say YouTube, oops, at a breakpoint. Oh no, really? Okay, no, wait, I added. Let me fetch a YouTube video. So when I go back, go to YouTube video. Let me grab maybe my next car, and so I click on share, and I can click that URL, and I can copy that, and I can paste that URL here, paste it, and give it a width of 100% so that it stretches the entire width of the page. So I can say okay. There it is. So it embeds it in here, right? So I can add any number of YouTube widgets. I know why it's failing. It's the URL that it uses to go fetch the video. It tries to clean it, right, and tags it as a safe URL for loading, right? And I must have not done some validation. At first, the URL doesn't exist. And I think it tries to clean it without checking for null, for undefined. So I have to go back and try this out. And I can have any number of videos. So I can have another one. And my next bike. Share. I can copy that and go back here and add another video. And then I can, blank placeholder, right? Where when you click it, maybe it goes into the editing mode. Yeah, that's what I'll do. I can then go here and provide the URL and say that I want it maybe 50%. and say okay, right? And no, I guess it ignores my 50%. Okay, there it is. And I can change also the order. I can move it around with and place it in a different way. But that I haven't completed. All right, so yeah, so take a look at the source code. If we have to for a little bit today. I also added the capability of creating so for instance, let's create here a image gallery. And that image gallery, let's add a header that is called maybe image gallery, size 3, okay. And then here I can add an image. And once I go, if I edit that image, it allows me to either provide a URL of an existing image on the web, right? So for instance, I can go here and grab an image. Actually, let me go to Google and search for an image. So let's say space shuttle. And I go to images. I can click on an image. I can view the image. And that's the URL right there. So I'm going to grab that URL. And I can paste it here as a URL. I can paste that. The width, I'm going to say that's 100%. And I'm going to say OK. So there it is. So it embeds the image right there. It uses the URL just for ng source, right, and uses the image for that. Or I can instead say plus add another image and then provide upload an image. Right, I can upload an image. It'll copy it to the server and then link to the local image that you add. So let's choose an image, a file, and let's see. This is a picture of me. I think that's it. So I'm going to click on that, and I'm going to upload the image. So it uploads the image, and it goes back, and there's me, right? And I can change the width to be 100%. There it is. So there's a blurry image of me, right? So these two examples. Please take a look at Web App Maker, and you can look at my commits, right? They're very deliberate, right? When I add a particular feature, all the files that I modify for that particular feature are part of one commit, right? So you can take a look at all the things that were added to support that particular feature, right? But let me go back and see how I added support for Passport. Support for Passport is what we've seen already in the example, but let me quickly demonstrate for you. Okay, so let me go back and take a look at the implementation, right? So let me close most of this. Let's close all that. So first of all, the first thing is to install the necessary libraries, right? So I installed Passport, right? And I installed several other strategies, right? Which I'm not using yet, right? But for next week, I'd like to demonstrate how to use logging in with Google instead of just using it in Password, right? But the way that will work is that when you click on, that you want to use Google, what will happen is that Passport will redirect you to Google's login page, right? Which will log in with your Google account, right? And then one of the things that Passport passes along to this to Google is, right, a callback URL, so that Google, if you authenticate successfully, right, it will use that URL that you passed it to call you back, right? It will navigate to a place in your application, right? Which will invoke a template, will invoke a controller, right? And in the request, it will pass along a token, right? This token, Passport uses this token to then, right? Any new API calls to Google, it will use that token, right, to talk back to Google. But we're not going to want to talk back to Google. We only just want to authenticate ourselves, right? One of the things that we'll need that token for is that we would like to, for instance, know the unique identifier for a Google user, right? Each of us has a unique identifier, an ID, right, in Google servers, right? We would like to know what that ID is so that we can store it locally in our servers, right, as our account identifier, right? Instead of us being identified by a unique username combination with password, instead we're going to be identified uniquely by a Google ID, right? There is no username and password anymore, right? Because we're not going to be authenticating ourselves with username and password. Instead, we're going to be authenticating ourselves with Google, right? And we're going to note that by keeping track of this user ID in our database, right? And Passport is going to use this to go back and forth to identify. Anyway, we'll talk about that next week on how to do that. In this implementation, I only used the local authentication, just like we demonstrated in our previous lecture. So in here we have a config that the default the default URL is to go to the login page, which is up here, right? So the default URL path is go to the login page. In the login page, we have a login button that goes to the controller. The controller goes to the client. And I put all security communication with the server. I put it all in a security service, right? So that everything that has to do with logging in, logging out, checking to see if you're logged in, right? Whether you're an admin, all those that has to do with security place, okay? In this security service. So in here is where you find, no, not that, sorry. In the security service is where you find things such as logging in and logging out, okay? And these are both posts to the web service, right? The web service is right, which goes to the I believe it's in the, where is it? Wait a minute. Is it the developer service? Yeah, I added to the developer service. There it is, the login and log out. Okay, log in, log out, and logged in, right? And it's the same implementation as that we saw earlier, right? We load Passport, we load local strategy, we intercept any communication with a login HTTP handler, right? I literally copied, right, from the previous implementation. Right? I literally went and copied it, obviously in a strategic place, right? Here is developers service, right? And this is where the developer service can find developers by username, right? Find them by username and password. Is dealing with the developer model, right? So I decided to put it here. I have local strategy, and is going to extract the username and password, and I'm going to use the developer model, which I already had, right? But I added this find developer by ID, passing the username and password as an object, which comes back with a user, which is a developer, right? It's a developer. If there is no developer, then I return a false. Otherwise, I return the user. Okay. I did remove the password, right? So I'm adding some. So all these objects are being serialized and sent back, in JSON back to the client. And I don't want to be passing passwords around, right? Especially in clear text, right? So that's not information that the client is ever going to need, right? It's only needed when the client passes to us the password to us, right? Which in this particular case, it is clear text because we're not using HTTPS, but we're not using secure HTTP, which the free version of OpenShift doesn't support HTTPS, but the paid version does support HTTPS. And if you do use the paid version, it's as simple as changing all your HTTP protocols, changing them to HTTPS. And that's it. Right? There's nothing to do. Once you go into a payment plan with them and whatnot, you just have to change HTTP to HTTPS, and everything's secure. All the communication becomes secure. You have to use HTTPS, right, for all the communication. Anyway, so presumably we would have come to this login, right, using HTTPS ://API/login, right, so that any username and password that is passing and arriving to us here at the web service would have been encrypted, right, and it would have been decrypted by the time we get here. Okay, that's free. We don't have to do anything there. But the framework handles that automatically. Anyway, the model, the local strategy is the same as earlier. Authorize is the same as before. Same implementation. Deserialize and serialize are the same implementation as earlier. Again, I verbatim copied from the previous example. I hope that you have as easy a time as I had. Right, I was just able to move it and integrate it very easily into my own project. Okay. Logged in, same thing as earlier, right? It's logged in. You just return whether it's authenticated or not. And log out, and log in just responds with a user. I only added this delete password. I didn't want to be passing around password back and forth. Another thing that we haven't dealt with is that we are storing the password in clear text in the database, right? We need to deal with that. Right? We need to deal with that because we don't want to store the password in clear text because the admin would have access to our passwords, right? So even when we store in the database, we would want to encrypt the password in the database, one-way encryption. Right, so that it cannot be decrypted, right? We'll look at that next week, right? So that when we store we want to encrypt the password, and then when we try to log in that person, what we do is that we do an encryption of the password that comes in through the login and compare it against the password that is already there. Right? We never decipher the password, right, and have it in clear text ever. Right, it's in the server already encrypted, so that the user, the admin could never log in with our account, right? Because they would never know what the password is. Okay, they can change it, they could set it to something else, right? But they could never log in with the password that we have. Okay, they can't answer the question, what was my password? They can't answer that, right? They could change it to something else temporarily for you to change, right? Anyway, we'll do that next week. Everything else, I believe, stays the same. Delete developer. I didn't do admin. I didn't do admin support here, right? I'm not distinguishing whether an admin here presumably is me deleting my own account, right? Of the admin user. Everything else stays the same. Update developer, find developer. This all stays exactly the same. There's no change there. So basically that was it. Just these here. Right, serialized. Just this half of this file is security based, right, up to this point, and that's it. Okay, there's not more to it. Okay, so I think I have enough time. I'd like to show you the YouTube widget, right? How to support that, right? Let's see. When I so the page, right? The page displays all the pages, right? And when you click on a particular page, you navigate to the list of widgets, right? That's what a page is, right? A page is a list of a whole bunch of widgets, right? So that list of widgets is right here. It's implemented in the, let me close all these. It's implemented in the widget, or here we have widget list. So widget list, oops. Cancel. The widget list, basically what it does is that it queries the database for all the widgets for a particular page, right? And then iterates over all the widgets, right? And then it renders different HTML, right, for the various widgets. If you are a label widget, I render a label. If you're a title, a header widget, I render a title, and so on and so forth, right? So in the so the controller for the widget list, the controller for the widget list is right here, right? So here we have a widget list. Where is it? Widget list. There it is, right? On initialization, what it does is that it gets all the widgets. Get all the widgets for this particular application and for this particular page, right? It responds with all the widgets. We send it back to the client, and the client starts iterating over all the widgets, right? And on the list view, here it is. I have the widgets. I'm going to iterate over all the widgets, and I'm going to, as I iterate, I'm going to do an ng switch. An ng switch. So what an ng switch allows me to do is it's a wrapping HTML element among several templates, right? Depending on the value of the ng switch, right? If the ng switch variable is equal to A, right, then I'll choose first template. If it's equal to B, I can choose the second template, and so on and so forth, right? So here I am switching, right? I am switching on the current widgets type, right? Remember, type can be either header, right? It can be a paragraph, can be a label, could be an input field, can be all things, right? And depending on that, it'll render if the widget type is equal to header. This is the HTML that is going to be rendered. This is a DOM piece that will be rendered. Okay, none of the other ones will be rendered. Only this one. Okay, for this repeat. In the next repeat, we'll check again. In the next repeat, we'll check again. In the next repeat, we'll check again. Right? So an ng switch and ng switch when work in tandem. Right? Has a variable, and then ng switch when has constants. Right? Just like switch case, right? So it's the same thing. ng switch when is like the case, right? Comparing the variable against all the various values. If it's header, it's going to render one of these, either an H1 or an H2 or an H3. There's only 6. There's only 6 headers, right? Which one? Well, I could do another ng switch, right? We could do another ng switch. Instead of doing that, I just used a whole bunch of ng ifs, right? And actually, that's what a switch case is, right? A switch case is just a whole bunch of ng ifs, right? Anyway, if the widget.header.size is 1, I'm going to use H1. If there is no size, this is going to be my default. If there is no size, right? If you have not given me a size, by default will choose H2. Okay. Meaning, notice that says, right, if no widget header size or widget header size is equal to 2, right, I'm going to choose H2, and so on and so forth, right? Same thing for label. Label is trivial, right? If it's label, I'm just going to use a label. If it's text, I'm either going to use an input field or a text area, right? I'm going to use an input field if you say rows 1, or if you don't say any rows. By default, I'm going to use an input field. If instead you have rows bigger than 1, meaning 2, 3, 4, right? Instead, I'm going to use a text area, right? So if there is no rows, or if the rows is equal to 1, I'm going to use this input field. And the rows is greater than 1, so 2, 3, or anything like that, then I'm going to use this text area. Make sense? Right? For both cases, the name, the ID, the value, the text value, I'm going to grab that from the model, right? Also, the placeholder, I'm grabbing it from the text input placeholder, but they're all form controlled, so I wanted to stretch the entire width. I could make this also configurable, right? Whether I want it to stretch or not, right? And have a default form control, right? For the text area, the only difference is that to give the value of the input field, I use value equal widget text. Instead, I had to add it inside of the text area, opening and closing. That's the only difference, right? It's rendered inline as opposed to as ng model. Okay. For the button, I'm using a hyperlink for button class, and I'm calculating the class based on the title, on the style. Sorry, and the style can be one of primary, danger, success, right? One of those bootstrap classes, right? And so I can calculate a class that I want to add here, right? So ng class is the capability of dynamically calculating the class that I want to add to this element. Okay, and I declare that as a function in the controller. I'm going to pass a style. Again, style can be one of primary, success, danger, right? So in the controller, in the widget controller, I have get button class, right? So get button class is implemented down below. It gets a style. If there is no style, it's going to assume that the style is just default, right? That's a legitimate bootstrap style, button style, right? And just returns the string btn dash and then the style to lowercase, right? So I'm calculating the class dynamically. Okay. For the link, the href links to the UI. I can also change the target as blank. For the image, the ng source, right, is the source. There it is. And I can change also the width. I can change the width. Okay, here's YouTube. All right, so YouTube, I'm using this iframe. See that? Right. So that's how you normally share YouTube videos. Okay, so in YouTube, you go to a video and you say that you want to share it, right? When you share it, you can share it either as a URL or as an embedded iframe. Okay? I want to embed it as an iframe. Right? I don't want to give you a link for you to go somewhere. Instead, I want to embed it as an iframe. But what did I give it? I gave it a URL when I was configuring it, right? So what I did is that I'm storing the URL, but the only piece that I care about the URL is this last piece, this ID. You see that? Because that ID can be used to generate this iframe. Okay? this iframe, right? This iframe, if you look at it, it's a very simple iframe. The only thing that changes here ever, right, is this last piece, right? That ID is the same ID that I copied from the URL. Okay, bless you. Right. So what I need to do is that when I generate this iframe, I need to pick out that ID so I can generate this iframe. Okay. Also, I'm gonna remove this width and height so I can set it myself. Okay. So here in the iframe, I'm going to use the source. I'm going to calculate the source. Source is hard coded here, right, to use that iframe. But I want to calculate it. Right? I want to generate it myself because I need to dynamically set this ID. Okay. I'm going to use a function called save YouTube URL. I'm going to pass it the widget. In the widget, I have the URL. Right. I have the URL. So in the controller, the save YouTube URL, and the reason it says save, right, is that if you just plainly just calculate the URL, right, and you set it to the model, it's going to fail. It's going to say a whole bunch of gibberish, right? And it's because unlike images, these URLs are used to include, an iframe, right? Include things that an entire page, right, separate page that can download all sorts of other scripts, right, and all sorts of other plugins, right, that might take. So by default, these URLs are considered unsafe, right? You have to tell it. You have to explicitly tell Angular that it's okay. I trust this URL. Okay, either by creating a whitelist and listing all the URLs that you trust, right? Or one by one, piecemeal, you can give it this URL, a particular URL, and say, I trust this URL, right? To do that, you need to use this function, right? SCE, $SCE. It's a service that encapsulates all this security, all these security measures, where you can pass it a URL, HTML that you trust, because I'm going to show that next week, right? What if you want to embed HTML? Somebody wants to type HTML, copies and pastes URL HTML, right, in your text area, right? Should I trust that HTML, right? Or what if I want to store HTML in the database? When I grab it back and I want to render it, right? Do I trust that HTML? Okay. And SCE allows us has a whole bunch of functions that you can call and say, hey, I trust this URL, I trust this HTML. Okay. So take a look at the $SCE service, right? So what I do is I first create the URL myself, like I would normally do. I first get the URL itself. I split it on the slash because I care about the last piece, right? The last piece of this slash, right, contains the ID of the YouTube widget. I want to grab that, right? So I grab it. I grab the last part. Now I have the ID. I have the ID. And the URL is just HTTPS, YouTube, embed, and the YouTube ID, right? And then I return this as the URL, as a trusted URL. Make sense? Right? And that is going to be then used dynamically in the ng source to, right, download and and show the iframe, right, with the video embedded in there. Make sense? All right. Let's see. We did the image. The upload. For the upload, I included in the server. Actually, not in the server. Sorry. I included in the edit widget. In the edit widget. So the edit widget is a single file. It's a single view that displays different editors depending on the type of widget that you're editing, right? If you're editing the header, it'll show the text and the name, but then a drop-down where you can select the size. For the image, it's a URL. For the YouTube, it's a URL and the width. It has different editors, right, for different widgets. So when I come to this page, right, they all have these two input fields where you can have the name and the text. But then I go into an ng switch again, right, where I'm going to show different editors depending on the type of the widget, right? So for the button, I can choose the style, primary, success. For the text, I can ask for rows and placeholder. For the header, I can select the size. Anyway, for the YouTube widget down below, right? I'm sorry, for the image. Sorry, for the image, I can give you the URL, which links to an outside image, right, wherever that ends up being, or I have a form, right? That I can upload an image. I can give you the location of an image that is local to my machine. Okay. To do that, I use this input field. See that? This input field is of type file. It allows me, if I click on it, it allows me to navigate my local file system. Right? It's a very secured file browser. Right? You cannot control it from JavaScript. Okay? So that, for instance, you cannot programmatically use this file browser to just navigate and list files in the remote machine, or in the local machine, sorry, right? So it has to be manipulated manually by the user. The user has to navigate to the file system, right? Once they choose it, they can then submit. And notice that it does a post. This is a post that is going to post to my web service. It's going to post to one of my web services that is waiting for this post. Okay? And also another thing, that the form needs to be configured as multi-part, right? Form data, right? It's going to embed the image. It's going to attach the image to the HTTP request, right? And so, and I'm going to use Multer, which we haven't used Multer yet, on the other side on the server to be able to parse the various parts. That's what Multer does, right? It allows you to parse the various pieces of a request. Okay. Now, on the server side, I'm also going to need, right? I'm going to need the current user. What widget are you editing, right? In which page, in which application? I need that information too, because I need to go fetch the model, right, a piece of data, and update it in the database, right? So I am sending that over too. Typically, we would send it as part of the URL. Okay. Instead, I'm passing it as input fields, as part of the request. Okay. Since it's a post, this is all these values are going to be part of the body as a JSON object with name value pairs as chosen here. So the names will be application ID, page ID, widget ID, and that's what's going to end up on the web service. Okay. So notice that I also gave my file a name, my file. Okay. I'm going to need that on the server side because the message, the request, is going to have many parts. Right. In particular, I care about the image part, which is going to have a specific name. This name. This image part is going to have this name, my file, and I'm going to configure it on the post when it gets to the server. So on the server side, on the widget service side, I am waiting for the post. Here's a post. There it is. App post. Okay, app post. Right? And the way it works is we use Malter. We instantiate Malter wherever we need it. Right? We don't need to instantiate it at the server.js. We can just instantiate it wherever we need it. We need it here in this web service. And then we configure Malter. We configure Malter at listening for incoming posts. Okay? And where should we store these files? Right? The files, when they come in, where should we store them? Right? If it's our own server, we can store them wherever we want. Right? On OpenShift, we can't store it just anywhere because it's not our server. It's a shared server with other people, right? And so we only store it in the local directory where we're at. Okay. To know where we are, to know where the local directory where we are, we have this global Node.js variable called --dir name. Okay, this is a constant. This is a server-wide Node.js global variable that is set to the current directory where you're in. It happens to be the service, widget.service.server.js. That's where we're in. Okay? But I don't want it there. I want to go up and then down to the public directory. I want to put it in the public directory because the widget, when it renders on the client side, is going to have a URL. I want it to come back to me, right? And fetch the image so it can be rendered on the browser side, right? So it needs to be in a public place. It can't be in an inaccessible place. So I wanted to put it in the public directory. So that's why it says start at the directory name, go up twice, and then go down to right. So I created a dedicated uploads directory. Okay. Once I've configured upload, I can now use it as a interceptor. I can use it as a filter. I can use it as a middleware to first do its magic, stream the file over, copy it to the local file system. Once the file has been copied locally, right, then call me. Then call me at my upload image, right? And I'm saying I've configured it here, and then I can tell it that it's a single file called my file. That's the name we told it in the form, right? In the form, that's what we called it. And extract it. Once it has copied it, call me at upload image right here. Okay. Now, Malter, because this is you can upload all sorts of files, right? To avoid collision names, name collision, it uploads it and copies it. It chooses just any random name, right? Which is fine, as long as we know what the name is, right? And we can store that name in the database. And next time we render images, right? We render URLs, we make sure that we use that random value. Okay? We could have renamed the file because it provides us also with the original file name. We could have renamed it, but since it's one upload folder for it's a shared uploads directory, it's okay. It's actually better to leave it random, right? Just to make sure that we remember, right, what the original file name was, and what the new name is, right? So now in the upload image, we can retrieve the application ID, page ID, widget ID, all that. The body that we passed in from the form. We can retrieve the username from the currently logged in user. Right? It's available everywhere. If you're logged in, I can just retrieve the current username. I can retrieve the file from the request.file that's added by Malter. Malter adds this .file. Right? It's an object that tells you the statistics about the file. What size, what type it was, the original name, where did it end up being, right? The path of where it's actually at. Right, so it retrieves I can retrieve the MIME type, the size, the original name, the path, and whatnot. I then use Mongoose to retrieve the application, retrieve the widget, and then the widget I update its directory of where the file is, and I just store it back so that when it gets rendered, right, I fetch the widget, I fetch the URL, and then it gets loaded dynamically. Make sense? Right? Anyway, go over the example, right, in Web App Maker, right, and and please feel free to reuse whatever you feel there that's useful to you. And I know some of you are working with something similar that can add content management systems and adding all sorts of, and I think this is a perfect example for some of you that are working on projects such as that. So please make use of this. All right. Let's leave it here. I'll stay a little while if you want to chat. If for those that had scheduled meetings, office hours for now. Thank you.